Hey everyone, in this video I want to go over model explainability within ML.NET. And that is a couple of ways that we can look into the decisions that the trained model is taking with the data to make its predictions. But real quick, let's go over why this is important. And whether you're curious about the model or obligated to show the details about it so the model isn't run in a black box where we don't know the information about the model, it's also good to know how the model makes its predictions to help find ways to increase its performance. Now there's this paper written a few years ago in 2016 that explains the wolf versus husky example. And the paper is called Why Should I Trust You? Explaining the Predictions of Any Classifier by Marco Ribeiro, Samir Singh, and Carlos Guestrin. In this paper they give an example of an image classifier that determines if the image is of a wolf or a husky. And there were issues with the model that it would incorrectly classify images of a husky as a wolf. When they did some explainability, they found out that the reason for the misclassification was that the snow in the image was a big predictor of it classifying the image as being a wolf. And once they found that out, they could add more data to the model and help improve its predictions. Now let's go back to Visual Studio to see what ways we can perform model explainability with our ML.NET models. So first thing, I'm using the housing data here, and let's go ahead and install ML.NET version 1.4. Alright, with that installed, let's quickly build this model. So I'll start by creating a new ML context, and let's read in our data with the context data load from text file. And now we need to create this housing data class. The file name is housing.csv, and it has a header, so I'll set that to true, and the separator character is a comma. And I will just paste in these properties here. And I use a load column attribute from ML.NET, as well as the label column for the median house value that we want to predict. So I have the data, and now let's get our features. New data.schema, and we'll use some link here. So we'll select the column from our schema, but we'll just get the column name from it. And we want to filter out where the column name doesn't equal label, as well as where the column name doesn't equal ocean proximity. We don't want the label column or the string column in this case. And I'll just set that to an array. And now let's build out our pipeline. We'll just do context, transforms, and we'll featureize the text. Output column is text, and the input column is going to be that ocean proximity column. And I'll append in another transform where I concatenate into a features column this features variable here. Let's rename that so it makes sense. The string array gets concatenated into a single column called features. And we need to do another concatenation into features from the text. And then last, we'll append a regression trainer, and we'll use the Poisson algorithm here. So we have our pipeline. Now let's create our model. I call it pipeline that fit on our data, and we'll get the transformed data from the model that transform on our data. Alright, so we got the model here. One of the things we can do for some model explainability is to get the weights of our model. And the weights that it generates, the higher the weight, either positive or negative, gives an indication that that feature is more important to the model. So first, in order to do that, we need to get the model, that last transformer, and the model from that. So it's going to get the model parameters from this Poisson regression. And I think in order for this to work, the last item in the pipeline has to be the algorithm. And we can get the weights just by calling that linear model that weights. And may have seen we can get the bias from that as well, but we'll just use the weights. And we can write these things out, use a for loop, loop until the features that length, and we do another write line here. So for the feature and the index has a weight at that index. I'm going to do a console.writeLine, and I'll append a new line to it, because there's a couple other things that we can do for model explainability here besides just the weights. And the next thing we can do is get something called the global feature importance. And the global feature importance is going to be throughout the entire model, which features are that it deems more important. And to do that, we need to get the last transformer. So like up here, we got the last transformer model. I just want to model that last transformer. And I need to add a feature importance trainer here using context, regression, permutation, feature importance. And I'll tack on that last transformer and then the transform data onto it. From there, we can start doing our console write lines. So global feature importance. We do another for loop. The feature importance dot count this time. And the count is a method. And in here we'll write out kind of similar to what we did before, feature using the feature array and index. And in order to kind of help determine which feature is more important, we're going to get a difference in the root mean squared, which is one of the metrics that we can look at for our model performance in the regression model. To get that, we get the feature importance at that index, root mean squared error, and I'll get the mean from it. Alright, so that's another way we can get our model importance. Let's do another console write line with the environment.new line to separate that out. And the last thing we can do is get the feature importance for each row that we predict. So this got the feature importance for the entire model, but we can also get it for each row that the model predicts. Depending on the data that it gives it, the feature importance might be different. To do that, I'm going to get the first row from our data, use a model.transform, and then context data that take rows. I can then use that transform data, take the first row. With that first row, we can get a feature contribution using the context that transform, calculate feature contribution, pass in that last transformer, and then set normalize false. And with that, we can get the feature contribution transformer by calling feature contribution.fit on that first row. And with that, we can get the feature contribution pipeline by calling model.append. So we append to our model there and add in that feature contribution transformer. And with that pipeline, we can create a prediction engine using context.model, create prediction engine, use that housing data, and I need to create a housing prediction. We'll add that feature contribution pipeline to it. And let's go ahead and create this prediction class. And this is going to have two properties on it. First is the predicted house value, which would be the score of the model, but we'll also have a float array of feature contributions. And with that prediction engine, let's get some sample data by using a new housing data class, and I'll paste in some sample data into the properties, and we can get a prediction using the prediction engine that predicts using that sample data. And now we can write some stuff to the console. Row feature importance. In another for loop, we're going to go to the prediction feature contributions.length, and then here we'll write out feature using that features array has feature contribution of prediction, that feature contribution at that moment in the array. So let's run these and compare each of those different ways of model explainability. So we get our weights, our global feature importance, and our row feature importance. Let's look at our weights here. And let's see. total rooms and total bedrooms look really small, and it looks like latitude and longitude are bigger than the other items here, and it's like median income is as well. So that kind of tells us latitude and longitude has a high negative effect, while median income has a decent positive effect. If we look here at our difference in root mean squared, I believe the higher number means is more important here. So once again, we have latitude and longitude with high numbers. So population households does too. And then we look at the row feature importance. Latitude has a really high number here. Longitude rather. And latitude has a decent negative number, while the other ones are pretty small. Median income has a better number compared to these other ones. So that kind of gives us some insight. It's like latitude and longitude, or the location of the house, is going to be more important in our model here. So alright, so that's a bit of an introduction on how to use model explainability within ML.NET. Hope you enjoyed the video, and thanks for watching.